Welcome to another Paper Classroom 5-minute tutorial aimed at the Level 3 Technical Certificate in Papermaking. Today we're talking about the development of refining, or more precisely, the evolution of refining equipment. This slide really says everything that I'm going to talk about in this session. This here represents the beater. So with the beater we had a beater roll. On the beater roll there are bars going across the roll. The beater roll sits in a concave shoe, also that's barred, and the beater roll then turns in this concrete shoe or bed plate. So that was the initial piece of equipment used for working on fibres. It's a batch process, so you have to fill up the beater, let the stock go around for a while, stop it, empty it, fill it up, start again. There was a move then there was a demand for continuous processing. The idea behind continuous processing is you need less manpower, so it becomes a cheaper process, and as well as becoming cheaper, you get a more consistent quality. So there's an advantage in moving from batch processes to continuous processes, and that's a theme you'll see throughout this session. It's all about reducing cost. So we went from the beater to the refiner. The first refiner was invented by Joseph Jordan. It was a narrow angle conical refiner. The angle here is about 15 to 17 degrees. So you can see essentially what they did was they took the beater roll, they took the bed plate, they wrapped the bed plate all around the beater roll to become the casing of the refiner. And just so the stock knows which way to go, you put a bit of a taper on it, you feed stock in from the narrow end, and it will then come out through the wide end. So following the beater, we have the narrow angle conical refiner. Later on we got another development by a guy called George Claflin. He came up with the idea of the wide angle conical refiner. Just a progression from here really. He's taken this, made the angle a lot steeper, 60 degrees. Typically Jordans or narrow angles are better for cutting, and wide angles are just a little bit better for fibrillating. But the important thing to remember is the move from here to these was to go from continuous processing to batch processing to reduce costs. The next development was then the single disc refiners. And yes, you can see two discs there. Paper makers do like to confuse people. We have two discs, but it's called a single disc refiner because we have one working surface. The two lines here, this represents a fixed disc and this represents a rotating disc. So we have one refiner fixed disc, one rotating disc, and the fibres get pushed into the middle, they work their way out to the outside, and the discs do the work on the fibres. It does fibrillating and cutting. And the reason why we moved from here to here, guess what? Cost again. This time it's not going from batch to continuous because we're already in continuous. If you look here, this is a huge chunk of metal, and this is quite a big chunk of metal. But here, this revolving disc, much less metal here. Therefore, it costs a lot less energy to turn that metal. And this is what we call the no load power. So the no load power is reduced. We will still spend the same amount of electricity and therefore the same amount of money doing work on the fibres, but it costs less money to turn this than it does to turn those. We then moved on to the double disc refiner, and as you can see here we have two rotating discs and one fixed disc. There are various flow patterns you can have with these sort of refiners, but essentially you bring the stock in. If this middle disc is a solid disc, the stock will flow up here, around there, down there, and then it will come out. If it's a perforated disc, the stock will come in and it will either go that way or it will go this way, similarly down there, and then out. So you've seen the theme, now you've seen the trend. We've gone from here to here because we've gone from batch to continuous to save money. We've gone from here to here to reduce the amount of metal, which makes the running cost cheaper, so it's to save money. So my next question now is, what do you think will come next? I'm not going to talk about a disc with 4 discs or 5 discs. What do you think the next development will be? Pause the video, have a little think, and then I'll tell you the answer. Okay, here we go. You see the difference? Here we have 1 fixed disc and 2 rotating discs. In the new design we have 2 fixed discs and 1 rotating disc. So we don't need 2 motors anymore, we just need 1 motor. So again, the whole focus is on reducing costs. The armature comes through here, it's called a floating armature, and that will turn this disc. So, a quick summary of this session. First of all, we had the beta, which was a batch process. Then we moved on to conical refiners. There was the Jordan 15 to 17 degrees, the Claflin 60 degrees, continuous processing so that we could reduce our costs. Then we moved, so the beta from the refiner was to save money, batch continuous. It's also improved consistency of quality. Then we moved on to discs, single disc, double discs, discs with a floating armature. Why do we do that? Because moving from conicals to discs was to save money because there was less no load power. Thank you for listening to this session, and if you need to contact us, we're available through all this social media. Thank you.